All right. So let's go about the syllabus. Also make sure that I test 1, 2, 3 that it's recording. I think I've recorded like 120 videos last semester, and I missed on one of them. The audio didn't record, and I got dinged on my trace evaluation. So make sure I have my audio there. So anyway, syllabus. Right. So we're meeting here in Richards Hall, 236 on Mondays and Thursdays, 11:45 for about an hour and a half. So this is me. This is my email. Although again, I prefer that you either call me, text me. That's my phone number there. That's my private phone number. Do not share it, but feel free to contact me. Office hours, I'm thinking might be maybe Mondays and Thursdays. Although based on my other schedule, it might move to Tuesdays and Thursdays. But I'll let everybody know. It's at Nightingale, 132 Nightingale. That's where most of us are there. My YouTube channel is there. Teaching assistants. So the TAs are going to be inputting their own contact information here, and so they're just still updating that. So yeah, as I mentioned earlier, the goals of the course is the first half of it will be to talk about relational database. Has historically been the de facto way that we store and retrieve data. But today, there's plenty many other alternatives that are becoming much more popular. With the explosion of data, we see that relational database is not necessarily the right approach, depending on the solution that you're looking for. So the first half will be talking about the historical use of relational databases, the same challenges that we are going to introduce there, and some of the techniques are also transferable to non-relational databases. So things like redundancy and indexing and things like that. The same, and normalization of your data are still applicable in non-relational databases that we'll take a look at on the second half. So those principles are the same, which is great. They're still transferable. Again, there's this team project, and I encourage everybody to start looking who you might want to partner with. Evaluation, there will be about 6 assignments. Most of the assignments will be in the first half of the semester, maybe 4 in the first half and maybe only 2 in the second one, so that it'll give you a little more time towards the end of the semester so you can start working on your project and finishing up. Although I encourage you to get started right away. Right, there's no excuse leaving it for the last week or so. You have plenty of time to get started on designing it, on what a domain that you want to work on, and architecting it. There'll be about 6 quizzes, project, midterm, final. The final grade scoring. So makeup policy. So typically there won't be a makeup. What we'll probably do is that we'll have plenty of quizzes, and probably we'll drop the lowest quiz, right? So if you had to miss out a particular quiz, instead of just making it up, we'll just drop the lowest, right? And for the assignments, there will be a bonus assignment. So if you think you didn't do very well on a particular assignment, there will be a bonus assignment towards the end. Usually it's pretty challenging, but it's meant to be. There is a late policy. Basically, if you miss the deadline, you'll lose 1 percentage point for every hour that it's late. So if you need another 3 hours, or another 5 hours, another 10 hours, there's no need to ask. Sure, you'll just lose that many points for every hour that you're late. All right. So that manage that time up to you. Obviously, there might be some exceptions. If you have a health issue or a family issue, or you are traveling because of sports or some other reason, just let me know beforehand, and we can we'll work with you and on a case by case. Okay. The assignments, they're all going to be on Blackboard, and typically the submissions will be on GitHub. You'll create I'm sure you have a GitHub through the university, or you can use the github.com and create an account there. And the source code that you submit will be through GitHub, right? And the submission will be just you giving us a link to where your GitHub repository is, and we'll take a look at the source code there. You might need to invite myself and the TAs as collaborators for that GitHub repository so that we can take a look at it. If it's private, if it's public, that's fine. If it's public, then it's got to be careful that other folks might have access to it. So the agenda. So this is the agenda. It looks a little better here. So yeah. So today and this week, we'll introduce the course. We'll what the schedule is and the assignments that we're going to be working on. We'll make some definitions on what we mean by a database. Some of the really initial definitions. We'll talk about data definition using UML class diagrams. Those are most common way of modeling a problem. We'll go through the process of perhaps interviewing a client. They might give us all sorts of ramblings on what it is that they might want. Usually they might not know what they want, right? And it's our responsibility to guide them through the different possibilities and identify what is relevant, what is irrelevant, right? And identify what are the domain objects, all the relationships between those domain objects using nouns and verbs, and representing it in a formal language. We'll use mostly UML class diagrams and sequence diagrams as a formal representation of what we understand of what the problem is, what we're trying to solve. So we'll go through those in the first couple of weeks. The first assignment usually assignments will take about 2 weeks in between them. The first one will be a data modeling assignment, where you'll be giving several phrases, several paragraphs of perhaps from the result of an interview, presumably, where you're going to be gathering requirements, and from those requirements you'll be coming up with what the data model would be. Usually, these kinds of interviews might take several days, several weeks. We don't have that kind of luxury. We just have one interview, and so ideally you would have the possibility of going back and forth, where you might ask the client on how you might want to interpret certain things from the interview. We'll do that through Piazza. Where there's this first assignment, feel free to go back and forth between myself, the TAs, and if you need feedback on how to understand certain phrases, because everything is can be interpreted different ways. Okay, everybody can interpret the same phrase in a different way. So that exercise will go through the first 2 weeks, and depending on the interpretation, you'll come up with a class diagram. All right, so that'll be the first assignment. We have a couple of holidays. The third week we have Martin Luther King. We have no class that Monday, but we do have class on the Thursday. So the first week or so we'll talk about UML, a very conceptual way of capturing, a formal way of capturing the data model. We'll talk about relational model as one of the first ways of translating something that's very conceptual into something that's much more concrete, right? Something that can be actually stored in some file system and then can be queried and retrieved. And so the relational model will be our first concrete way of storing and retrieving data and representing it using schemas and doing operations such as inserts and updates and deletes and group by and all the SQL goodness that we should all know, right? We'll all learn about. Although it is, we consider it to be a concrete representation of the data in a file system, in a relational management system, it's still very conceptual, right? Data is not really stored in tables, right? There are no real records or fields. Those are still very high-level abstractions, right? Down below in a file system is just zeros and ones, right? It's just that we have thought of this very conceptual and convenient way of representing or understanding data in terms of these tables and these records that are somehow related to one another and pointing to each other, right? And we break up the data into records. Again, it's a concept. Just like UML is a concept, relational model is also very conceptual, but it's a little more concrete. It's as close as you want to get to the actual storage in the file. Then in week 5, we'll talk about store procedures, triggers, views, and on how is it that you can do some programming even within the same database and trigger some of these procedures and functions depending on certain events when things are changing, data is changing, or it's being inserted or updated, right, or deleted, and how we can run certain procedures and functions and logic based on the requirements. So at the end of week 5, we'll start thinking of other ways that we can interact with the database, and we'll start considering how we can programmatically, from other languages, we can interact with the database. In this course, we'll talk about Java, how to interact with the database using Java, but certainly it's plenty of other languages that you might consider. Each infrastructure has all sorts of libraries on how to connect to a database and through a network connection and then interact with the database. We'll be considering Java for this class. We'll first take a look at the lowest level of interaction using JDBC, and we'll use several. We'll be implementing a couple of best practices on how is it that we might want to modularize the interaction of the data using several design patterns. One of them is the DAO design pattern, data access object design pattern. It's a very common design pattern in industry of not spreading your logic of interacting with the database all throughout your code, and instead modularizing and encapsulating that data access through a set of dedicated classes that are responsible for interacting with the data with the schema, with the database. Once we've created a couple of DAOs, we'll realize that they all look the same. They'll have the same structure. They're all pretty much doing 4 or 5 operations. Creating, reading, updating, deleting. Once we have identified a pattern, like good software engineers, we'll ask ourselves, how can we generalize this? Right. Once we look at a pattern, says I don't want to ever write a DAO ever in my life. I've written plenty. How can I generalize this? And it says, well, it would be nice if I would have a DAO that could be parameterized, right? If a DAO will realize that it's pretty much the same select statement, the same insert statement, the same deletes, the same updates. They all look the same. The only difference is maybe the name of the table, the fields, the data types. Those are the only things that change. If I could parameterize this data pattern, I could have a generic DAO, right, and just give it some parameters, and it'll create any DAO. And that's exactly behind the idea behind object relational mapping strategies. That's a very common technology used today in all sorts of frameworks. Every framework has an ORM mechanism that allows to think about interacting with the database in terms of objects. You think about classes as opposed to thinking about tables. You think about properties and setters and getters as opposed to fields, right? And so it allows you to think about interacting with the database at an object level, right? ORMs allow you to map these two worlds, allow you to map the world of the object world to the relational world, the relational database world. And again, it's conceptual. Every framework has its own way of doing it. We'll be taking a look at Java's way of doing it, which is the Java Persistence API, JPA. It's just one of many ORM technologies out there. It's pretty popular, and I think it will be very useful in your curriculum. Once we've identified how we can programmatically interact with the database using programming languages, we'll take a look at other ways that we can integrate with data. Right, data certainly has its uses inside of your enterprise or your particular application, but we can increase its value if we can have other folks be able to integrate with it. Right, so certainly you can write a program or application around a database, but that data becomes much more valuable if it's somehow shareable with the rest of the world. right? It can be published, right? And other folks can maybe pay access to your data, right? So we'll talk about certain ways of integrating with that data. In particular, we'll take a look at web services and RESTful as a means, as a very common way today industry of exposing data sets to folks that are outside of your enterprise or even within the enterprise. So that's the week right before the spring break. We'll have the midterm right before you leave for spring break. So that's 8 weeks. It's a big chunk of the semester. We'll come back after the spring break on our 10th week, and so up to this point, we'll have been working exclusively with relational databases, right, up until week 8. We'll abandon the relational model for a bit and explore other mechanisms of storing and retrieving data. We'll talk about NoSQL, big data, MongoDB, Mongoose as other mechanisms of storing, retrieving data using alternatives to SQL. Right. In particular, we'll talk about Mongo, but certainly there's plenty of other non-relational databases out there that you're competing. We'll talk about Mongo. And we'll spend about maybe just a day and on how very really simple client application, usually web. Most folks tend to, for their final project, they tend to want to build something using web. This is not a web course, but we'll give you just enough to be dangerous. Just to implement really simple interfaces that interact with the data set. We'll build a prototype of a really simple project that you might want to use as a starting point that you can grab and then maybe build something on your own. We'll come back and on week 12 we'll talk about other forms of storing data. In particular we'll talk about XML. XML became very prominent when at the turn of the century, right before the .com bust. Folks were looking at how is it that folks can integrate with one another, and either within an enterprise or across enterprises. You had maybe Ford Motor Company integrating with their financial institutions, integrating with their government for approval or regulations, interacting with their vendors, interacting with their suppliers, and each one having different schemas, different databases, different infrastructures, and they were looking for ways of optimizing the entire production line. And says, well, how can we? You're talking Java, I'm talking C#, and that one over there is talking PHP, and the other one is talking VB. How is it that we can interact with one another? And they were looking for ways of integrating, and XML became the de facto language that everybody could agree on. Right? It wasn't based on any particular language, any particular infrastructure, and it was just plain text. It became very popular. And it allowed folks to break the barrier between the different schemas, right? Your representation of a product and my representation of a car and your representation of a car might have different fields, different data types, we needed ways of transforming the schemas between the different these different infrastructures. And so XML and XSLT, XPath, these are all technologies that were used to do all these transformations, and they're still relevant today. JSON has largely taken over the world, and JavaScript is it's like this virus taking over everything. We'll talk about transactions and concurrency and how database can be optimized using indexing, shards, how it can be broken up into smaller pieces that could be relevant, to be geographically located, so that if you're on the East Coast or the West Coast, you might want to do, when you're doing queries to a database, ideally it would be a data that is relevant to your geographical area, right? And so we'll talk about different ways that databases can be optimized for performance based on indexing and sharding and whatnot. Then the last week will be a little bit open-ended, but I was thinking maybe GraphQL, real-time databases, Firebase, to close up the semester. The by spring break, I would assume that everybody's working on their project. They know enough of relational databases to start thinking of what their domain objects are and how to relate these domains, these objects. What are the relationships? What are the queries? The setters, the selects, the inserts, the updates. You should have, by the beginning of the spring, the end of the spring break, you should already have an idea of what your class diagram might look like, what your use cases are, and have perhaps already provided some idea, proposed something for us to work on the project. So yeah, I would expect that week 10 through 14 that you're fully working on your project. Okay, that you're not leaving it to the last couple of weeks and cramming it. So week 15, that's I believe 4/16, that's the last day that we're going to be meeting. So the final exam will be that day, the last day that we meet, 4/16. I believe the semester ends that week. This Patriots Day on 4/20, and the project is due on the 21st. That's about a week before grades are due. So that gives the TAs and myself about a week to grade all the projects. So that should be enough. And grades are due the 27th at 2 p.m. All right. Any questions? Yeah, yes. Right. So the proposal will be as written. Right. You'll have. My understanding is that by the 6th week number 6, you will already have a proposal. You already even have a description and a design, and as long as it's within the requirements, I'll go over the requirements of the project. They're pretty broad. As long as you're within those requirements, you're free to do whatever you want. All right, there's no need to come and ask for permission. Only if you feel that what you might be working on might be outside of that scope, right? Then perhaps you might want to come talk to me. All right, we're fairly open-minded. If you feel that you want to do some other feature as opposed to some feature that we propose, we're open to it. Come and see us. As long as the complexity stays the same, then certainly we can agree on that. All right. Yes.
Is the final cumulative, or is it?
It's cumulative. Yep. Yes. Academic integrity. Unfortunately, every semester we do have 1 or 2 folks who are caught cheating, either because they collaborated when they were not supposed to collaborate. They copied from some GitHub repository that they found from a previous semester. The TAs are very good at finding these things. Please, it's very awkward for myself. Certainly for you, I'm required by the university to report you to Oscar. I'm not familiar with Oscar. Even if you haven't done this elsewhere, I'm required by the university to report you. It might be happening. It might be something that's recurrent in other. It has happened before. I wouldn't know that. They would know these kinds of things, right? But please do not put me in this awkward position. Okay. It's everybody's crying and everybody's this and that, and it's my last semester, and I'm graduating, and my parents are flying in for my graduation, and everybody's it's a very awkward position. Please do not put me in this position. All right. If you're if you're in doubt whether you are breaking some rule, then you probably are breaking a rule. Right. If you're not sure, ask. Right. Okay. We're all adults. We all understand what it means that it's your work and not someone else's. All right. It's fine, to converse with other folks and talk about generalities and approaches, and look at somebody else over somebody else's shoulder. but deliberately copying an entire swaths of code, maybe 3 lines of code here and there. Okay, nobody will complain about that. But if it's something more than that, please avoid doing so. And here's a link to the academic integrity policy. Please take a look at that. Title 9, and that's it.